Every now and then on this channel, I talk about the challenge of interstellar travel, and every now and then I might talk about intergalactic travel. But as all of us know, this entire concept is virtually impossible, or at least completely impractical, because of the ruthless and unyielding nature of Einstein's theory of relativity and his relationship of mass to energy, things that we know are true, things that have held up under numerous scientific experiments, and things that tell us definitively that traveling at the speed of light or faster than the speed of light is simply impossible. And not only that, traveling very close to the speed of light, although theoretically just fine, requires so much fuel that even exploding nuclear bombs behind your ship in order to provide thrust would only get you to maybe 10 or 20% of the speed of light. Yes, very fast, but nowhere near as fast as 99% of the speed of light. Well, this guy thinks that there might be another way, a way based on an entirely different scientific principle that was dismissed over a century ago, but now he's beginning to show that that principle perhaps should not have been dismissed and that it actually works. His name is Dr. James Woodward, and his device is called the Mach Effect Thruster. And no, that's not Mach as in M-O-C-K, but rather M-A-C-H. And the idea behind this is strange, bizarre science, voodoo science almost, the sort of thing that I dismissed for a long period of time, actually, something that I really didn't want to talk about on this channel because it was kind of pushing the boundaries of what was reasonable in my opinion. However, after a little bit more investigation, and also after discovering that NASA has invested a considerable amount of money in researching this Mach Effect Thruster, I've come to the conclusion that this may not be voodoo science after all, especially given that it works, at least in principle, and also in a laboratory, and it's worked on a number of occasions with a great deal of peer-reviewed information. It's very exciting, and let me tell you why. You don't need fuel. You don't need nuclear bombs exploding behind your ship, nor do you need a super powerful laser pushing a massive solar sail that's hundreds of kilometers in diameter in order to achieve these kinds of speeds. Instead, all you need is a relatively modest nuclear reactor and a whole bunch of these Mach Effect thrusters that manipulate gravity and, if Dr. Woodward is to be believed, the very fabric of space-time. So even though traveling at 99.9% of the speed of light is theoretically just fine, there is one big problem, and that is, of course, the most fundamental equation that everybody knows about Einstein, E equals mc squared. Energy equals mass times the speed of light squared. What that means, at least as far as this particular situation is concerned, if you want to travel at the speed of light or very close to the speed of light, you need as much mass converted directly into energy as the mass that you're accelerating to the speed of light. In other words, let's say your entire ship is made out of antimatter. The entire ship would need to be converted into energy in order to get it to the speed of light, or very close to the speed of light even. Consequently, you would lose your entire ship, or 99.99% of it. Not really a very effective way of traveling this fast, and not only that, you would need to have enough antimatter to accomplish it. None of these things are really possible according to our current understanding of physics, but there is something else that Einstein included into his theory of general relativity, and this is something called Mach's principle, from a physicist from the 19th century named Ernst Mach. And even though the theories of Dr. Mach were discarded quite some time ago, Einstein himself integrated them into his theory of general relativity, his theory of gravity. And here's what Mach said. He said that inertia is the result of the gravitational interactions of everything in the universe. So in other words, if you're walking down the street, the inertial mass that you have to overcome in order to travel at 2 miles an hour, 3 miles an hour, whatever, is being impacted by star stuff, or the gravitational influence of star stuff, billions of light years away. And as ridiculous as this sounds, Einstein believed it. But at the same time, Einstein had some very serious problems with gravity from the beginning. But here's the thing, Dr. Woodward believes that Mach was not wrong, and that gravity actually has a direct relationship to the inertial mass of everything in the universe. That gravity, inertia, and everything else are interrelated in the very fabric of space-time. So that means you should be able to change something's inertial mass by applying energy in the proper way, manipulating space-time essentially. Now this it seems absolutely absurd. There's no way you should be able to change the inertial mass of something simply by applying energy to it. Inertial mass remains constant, or so everyone thought, until Dr. Woodward took advantage of an electronics manufacturer that was relocating, and they had some leftover materials that he snapped up. It was a pile of piezoelectric discs, and he mounted these to a block of brass and put a cap on the other end to hold the whole thing in place. And then he put a channel of electricity into the piezoelectric discs, a pulse of it actually, and they bulge slightly, and the expansion causes them to push off of the brass block and accelerate in the opposite direction. Now, according to Dr. Mach, something called the Mach effects, this electric current should also make the piezoelectric discs slightly heavier, and it causes them to pull the brass block towards them. And then when the electricity stops flowing, the whole thing will have moved slightly forward. Now, repeating this over and over again, it should accelerate based on a far older and more fundamental scientific principle, Newton's third law. For every action, there is an equal and opposite reaction. And here's why the whole thing works. You apply the electricity, the mass of the object increases and then decreases depending on the application of electricity. What this means is you can send the object out when it weighs more and then pull it back when it weighs less. As impossible as that may sound, it actually works on a minuscule level, but it does work, and it has been tested and peer-reviewed over and over again. The question is, can it be made practical? Now, all of this, again, seems like voodoo science here. How the hell can you make something weigh less one moment and then weigh more the next just by putting an electric current through it? Well, This device makes it happen. And so if you can accelerate something away from the engine when it weighs more and then pull it back when it weighs less, it means that you get constant thrust without ever running out of fuel. All you need is electrical power. How much thrust can you get out of this? Well, according to Dr. Woodward, his long-term goal is 10 newtons of force per kilowatt. Now, does the Mach Effect Thruster have that kind of performance right now? No, hell no. It's 1% of that, less than that actually. It's barely measurable at the moment. Of course, then again, it is a very, very tiny engine with a small amount of energy being passed through it. Nevertheless, it's also been determined that utilizing the types of materials that are in this thruster, upscaling it would be a very difficult thing to do. Heat alone would make it virtually impossible, at least from the experimental results they've had thus far. So what you would need instead is thousands and thousands of little Mach Effect thrusters instead of just one big one. That having been said though, let's just take a leap of faith and assume that we could get these kinds of results, because so far the experiments look promising and there's no reason to believe that we can't accomplish this kind of result. If you got 10 newtons out of every kilowatt and you had a small modular nuclear reactor, and there are quite a number of these. There's one, for example, that weighs about 300 tons and produces 160 megawatts worth of energy. 160 megawatts. So let's see how many newtons that would produce. Well, the calculation would be pretty straightforward, of course. 160 megawatts is 160,000 kilowatts, which means you would get 1.6 million newtons out of this kind of reactor. So let's say you have a 300 metric ton reactor, and then you use a BA2100 module from Bigelow. In other words, 2,100 cubic meters worth of space for the crew, for their supplies, life support, all of that, and that would weigh roughly 70 metric tons. And let's say the engine itself and also the heat radiators that you would require, let's say all that adds up to about 100 metric tons. And yeah, I'm being very generous here. So we're looking at 70 metric tons plus 100 metric tons for the engine plus 300 metric tons for the reactor, or 470 metric tons overall. So to get your acceleration, you divide your 1.6 million newtons by 470,000 kilograms and you come up with 3.4 meters per second squared. So what does that mean? How long would it take to get to 99.9% of the speed of light if you were going that fast? And by the way, that's not 1 G worth of acceleration. It's about 1/3 of a G of acceleration. Well, the answer is a bit difficult to comprehend, because keep in mind, this is substantially less acceleration than a conventional chemical rocket. But here's the deal: if you don't run out of fuel, and a small modular reactor's fuel would last for about 10 years or so, you could get up to 99.9% of the speed of light in less than 3 years. Unreal. And the things that are possible at that kind of speed are sort of difficult to comprehend, because as many of us know, funny things start to happen when you get very close to the speed of light. We're talking time dilation. And if you can get your ship up to 99% of the speed of light, then why not take it up to 99.9999999% of the speed of light? Yes, that's a lot of nines there, but every second that passes on board the ship is 19.6 hours relative to Earth. Now, please forgive me as I try to blow your mind. For every year that passed for the crew on board the ship, 70,000 years, actually over 70,000 years, would pass in the outside universe. This would mean, of course, that you could travel from one side of the Milky Way to the other in about 1 1/3 years. If you take into account the 3 years that it would take to accelerate to this speed and the 3 years it would take to decelerate, you would be looking at 7 years, a little over 7 years, to travel from one side of a galaxy to another, something that would seem absolutely impossible without a device like this. Of course, 70,000 years would pass to the outside world, your civilization that you left behind, all your friends, their descendants, everything else would be gone. So why the hell would you do something like this? Well, there might be some very good reasons. If we want to become a multi-planetary civilization, why not become a multi-stellar civilization? If we in the future discover a planet that's thousands of light years away, we could send out a ship traveling at this kind of speed and have it arrive within a human lifetime, actually a relatively small fraction of a human lifetime, sending off enough human beings to establish a self-sustaining colony in another solar system thousands of light years away, guaranteeing the long-term survival of the human race. And who knows, somebody else may have already thought of doing this. Think about this for a moment. What if you were part of an interstellar civilization on the other side of the galaxy? You took an observation of our solar system, discovered that the third planet of this solar system was right in the Goldilocks zone, was perfectly habitable, had all of the biosignatures to indicate that it would be a perfectly great place to establish a new colony. You set off from there, and they would arrive 100,000 years later from our perspective, but only a few years from their perspective, and they would arrive to discover a fully developed civilization that was not there when they set out. Impossible as it may seem, even intergalactic travel becomes a reality if you have this kind of technology, assuming that it actually works. But once again, all of this seems to fly in the face of reason. It seems to fly in the face of our understanding of physics. But really, what is being argued here in its most fundamental terms is you are taking a scoop of space-time and hurling it behind your ship, essentially using Newton's third law of motion and utilizing space-time as your source material. That is essentially, at least in principle, what this machine is doing, and how the mass of these piezoelectric crystals become heavier when you apply electric current and then become lighter when you pull them back to use them again. It is such a strange thing. It sounds like we're using new age crystals here, but we're not. These crystals expand and contract under the influence of electricity, and according to Einstein, that means they are interacting with the universal inertial fields in the universe caused by gravity. If you can make something heavier in one moment and then lighter in the next, you can use the very same Newtonian every reaction causes an equal and opposite reaction, which is the principle we use for rocket engines to create thrust that never runs out. But sadly, like so many brilliant scientists, it's likely that Dr. Woodward is never going to see the results of his experimentation and all of his theories. He's 79 years old, he's a cancer survivor with relapsed Hodgkin's lymphoma, and his long-term survival prospects are grim to say the least. But he dreams of at least one experiment taking place in space, and honestly, I think he should get this opportunity. He has conducted experiments with this device many times, and even though the results have been barely readable, they have produced results, and there have been many recent breakthroughs that have improved the performance of the Mach Effect drive dramatically. Now, is the whole thing peer-reviewed yet? No. Do the vast majority of physicists believe that this is a real thing? No, because it flies in the face of everything that we have believed about space-time, that we've believed about physics and the universe for many decades. Even though Einstein believed that this was the case, even though this is completely in keeping with Einstein's theories about gravity and the interaction of gravity over billions of light years throughout the universe, there still is a great deal of skepticism about this whole thing, and we may never see a positive result out of the Mach Effect drive. But the results so far have been very promising, and what you're looking at right now is a proposal for an interstellar mission based on a far more conservative result of the Mach Effect drive, delivering far fewer newtons per kilowatt than the ultimate long-term objective. And of course, there's going to be naysayers, many of whom are probably watching this video, that are going to say that traveling at these kinds of velocities are impossible anyway for many other reasons, not least of which is the fact that interstellar particles, the tiniest dust particles, are going to be positively lethal at these kinds of speeds. However, there have been some other interstellar designs that have included sort of a shield in front of the ship that would ionize all of the particles that would be in front of the vessel as it travels through interstellar space. Keep in mind that there isn't much in the way of asteroids or comets, that sort of thing, that a ship would run into in interstellar space, but rather a very small number of particles that, once ionized, could be deflected by electromagnetic forces before they came into contact with the ship. For every problem, there is a solution, and incidentally, the scenario I've talked about, it just includes small modular nuclear reactors. What happens once we break through with fusion? What happens when we create a practical fusion reactor? We may be able to accelerate to 99.9% of the speed of light within a few months instead of a year or two. You wouldn't want to go too fast, of course, because the G-forces would crush you in the process, but still, the more power you get, the better something like this might work. Once again, assuming that it does work, and assuming this isn't voodoo physics after all. But the only way that we're ever going to find that out is to invest in the research and in the study that's going to be necessary to peer review all of this and determine whether or not our understanding of space-time was not as thorough and comprehensive as we thought it was, and traveling between the stars is no longer an impossible dream, but a certainty for the future. If you like what I have to say, if you enjoy this type of content, please subscribe to my channel and check out the description for ways to support me and to keep this content coming. So until we take some serious time and serious investment to determine whether or not breakthrough technologies like this might change the future of human civilization forever. NASA has already invested substantially in this, but more needs to be done. And until this happens, I urge all of you to stay angry about space.